vector A, this is a vector B. This is a vector A, this is a vector B. Do you realize that if I imagine this to be a vector 2, this will be the same as B? Why? Because its direction is the same as the direction of B and its magnitude is the same as the magnitude of B. So this vector could be looked upon as the vector B. This also could be looked upon as the vector B. Yes or no? Okay. And then from the parallelogram law of vectors, I have arrived at the following. This C is the resultant of A and B. This C is A plus B. Right? So, if this C is the resultant of this A and this B, then whether it's this B or this B, the resultant of this A and this B will be this C, or the resultant of this A and this B will also be the same C. Yes or no? Right? So, which means I could have said that if there was a vector A like this, if there is a vector A like this, and there is a vector B like this, which is this, then the resultant of this A and this B would be this C, which is this. This is C. Yes or no? You know what I'm saying? Are you all there with me? Right? Now, this brings us to what's called the triangle law of vectors. The triangle law of vectors, which is only a restatement of the parallelogram law of vectors, triangle law of vectors. Triangle law of vectors. Write down, formally you might want to just write down the triangle law of vectors. If two vectors are represented by two sides of a triangle, taken in order, then the third side of the triangle, taken in the opposite order, third side of the triangle taken in opposite order represents in magnitude and direction, the resultant of the two vectors, This is all that I meant. This is one side of a triangle, and let's say this from here to here represents a vector in magnitude and direction. One side of a triangle. Now, this is another side of a triangle taken in the same order. That means you are going in this direction from here to here, right? The second side of the triangle, this is this, which represents another vector in magnitude and direction. So, if two sides of a triangle represent in magnitude and taken in order like this and then like this. See, the arrowhead is important, right? This is like this, then this vector is like this. That's when I say they are taken in order, one following the other one, right? If two sides of a triangle taken in order represent in magnitude and direction two vectors, then the third side of the triangle taken in the opposite order. See, this or from here to here I moved clockwise, but from here to here I moved anti-clockwise. So, then the third side of the triangle taken in an opposite order represents in magnitude and direction the resultant of the two vectors. This is triangle law of vectors. Got it? So, realize that it's no new law, it's only an outcome or a restatement of the parallelogram law of vectors. So what is opposite? I mean, I said just the order is opposite. Yeah, I mean, in the sense, if this and this are like this, then the resultant will always be like this. This is what is meant. Otherwise, opposite would mean this and this. It's not like opposite of A and B. It means the order of A and B. This is from A to B, you are going like this. And then from A to C, you are going like this. So it's just the opposite order. If two vectors taken in the same order are represented by two sides of a triangle, and the third side of the triangle taken in opposite order. However, in the same order, it would have been like this. C would have been like this. But if it's like this, it's an order opposite to A and B. It's not the direction opposite to A and B. The order is opposite to the order of A and B, not the direction. A direction opposite to A would be like this. A direction opposite to B would be like this. It's like A and B taken in the same order. Then C in the opposite order. That means I'm going like this, and if I went like this, then A, B and C would have been in the same order. See, this is what I meant. If this is A like this, if this is B like this, and if this is a vector C like this, then A, B and C are in the same order. See, I have not changed the direction. I moved along the vectors all the way. So then this vector is in the same order as A and B. However, this vector has an order opposite to the order of A and B. That's what it means. Clear? So that's triangle law of vectors. Now, the important thing is, suppose this is like this. This vector is the vector OA. This vector is the vector AB from A to B. It means a vector from A to B. This is a vector OA. It means from O to A. From O to A. This vector is OB. It means a vector from O to B. Yes or no? Then from triangle law of vectors, what have I got? OB must be the resultant of OA plus AB. Yes or no? Or OA plus AB minus OB must be 0. Yes or no? Now do you realize that if this is OB, if this vector is OB, then this vector must be minus OB. Yes or no? If this vector is OB, then this vector must be minus OB. Yes or no? Same length but oppositely directed. But minus OB is actually BO. Is actually BO. From B to O is BO. So this vector is actually BO. So minus OB is BO. Yes or no? Minus OB is the vector BO. Clear? Are you confused? So then this minus OB I write as plus BO. So OA plus AB plus BO must be 0. Yes or no?
Yes, sir.
Now what it means then is the following. Instead of, suppose you had three vectors. Suppose you had three vectors, OA, a vector AB, and a vector BO, and a vector BO. A vector OA, a vector AB, and a vector BO. Suppose you had these three vectors. Then the net effect of these three vectors is 0. See, OA plus AB plus BO is 0 means that if these three vectors OA, AB and BO were acting along the sides of a triangle. See, OA, AB and BO were three vectors acting along the sides of a triangle taken in order. See, in this case everything is taken in the same order, right? Like this, like this, like this. They are taken in the same order. If these are three vectors represented in magnitude and direction by three sides of a triangle taken in order, then their net effect must be 0. Their net effect must be 0. That means we then in common parlance say that, for example, if these were three forces acting along three sides of a triangle taken in the same order, then their resultant force would be 0 force. They would then produce what we refer to as equilibrium. Equilibrium is what is then produced. Yes or no? So if three sides of a triangle taken in order are represent three vectors in magnitude and direction, then they must add up to a 0 vector. They must add up to a 0 vector. Fair enough?